Hello and welcome to the Sleepy Narrator. I'm truly pleased you found your way here. Maybe you're already lying down, the lights softened, wrapped up in a cozy blanket, or just enjoying a quiet moment to yourself. Perhaps the noise of the day has gently faded, and the silence feels almost tender now. Wherever you happen to be, I've prepared this space just for you. A soft corner of the evening where calm and curiosity can rest side by side. Tonight we'll slowly wander into one of the deepest riddles the cosmos has to offer. Black holes. We won't rush. We won't lecture. We'll just wonder aloud, like two people watching stars together, letting the night pull our thoughts further and further outward. Now I should mention, I've done everything I can to make this story as gentle and sleep-friendly as possible. Still, black holes have a way of being just too captivating. So, if your thoughts end up wide awake with wonder, don't stress. They'll float back to rest in time, maybe a little wiser, a little more amazed. If you're already enjoying this peaceful moment, it would mean a lot if you gently liked the video or even subscribed if you'd like more of these calm science journeys. And if you're listening from somewhere special, a mountain cabin, a little village, or just your favorite chair, share it in the comments. I love watching the bedtime map light up slowly across the world. This video, like all others here, is purely for calm and education. It isn't a replacement for medical advice or professional sleep help, just a quiet place where your mind can drift. So now, let's start. Settle back. Take a deep, unhurried breath and glance upward. The night sky unfolds above you, vast, ancient, brimming with mysteries. You won't hear it, but the stars hum with quiet energy. You can't see it, but space isn't truly empty. It's alive with gravity, with motion, with memory. Those stars above, they're not merely distant lights. They're messages from long ago. Their light has been traveling across time, years, centuries, even millennia, just to reach your eyes tonight. One star you're looking at might have ended long ago, but its light still arrives, like a message delayed in delivery, yet full of meaning. And between those stars, in the spaces your eyes first think are empty, something else lies waiting. Black holes. You won't notice them. They don't shine, they don't flicker. They drift in silence, hidden in plain view, but they're there, like silent punctuation in the sentence of the universe. A black hole isn't really a thing. It's more of a place. A spot where gravity has completely taken over. Imagine something packed so tightly, weighed down so much that even light, the fastest traveler known, can't escape it. That's a black hole. Not a hole in the ground, but a region in space where time, matter, and even light fall inward and simply don't return. They come into existence when massive stars reach the end of their life in very specific ways. Some stars, the biggest ones, burn through their fuel quickly and end in a massive, beautiful collapse. Most stars become something softer when they die, a white dwarf or a neutron star. But if a star is enormous enough, its collapse doesn't stop. It continues past atoms, beyond light, deeper than time. And what's left isn't a glowing remnant or a flickering core. What's left is absence, stillness, wrapped tightly in gravity. Right now, as you're breathing slowly and deeply, there may be dozens or hundreds of black holes drifting silently through our own galaxy. Some may have crossed entire star systems. Some may be tugging on faraway planets we'll never see. But what if I told you black holes sometimes find each other? In the immense stillness of space, where things seem to float unmoving, black holes still travel. They drift. They move. They orbit. And when two black holes come near each other, not suddenly, but over millions, even billions of years, they begin to dance. The dance is slow at first. Their tremendous gravity begins to pull them into a gentle orbit. Like shadowy partners in a cosmic waltz, they spiral closer and closer. They don't send out light as they move, but they do send something else. They send out invisible ripples. These ripples don't move like sound or light. They move through space itself. They are called gravitational waves. Picture space as a delicate, stretched fabric, silk pulled tight in all directions. Now imagine two heavy black holes circling each other atop that fabric. Their motion causes the fabric to quiver, to stretch and contract ever so slightly. The ripples they make spread outward through this cosmic cloth, carrying the tale of their movement across unimaginable distances. You don't feel them, but these waves move through you, perhaps even now. If you could feel them, they might be like the faintest heartbeat beneath all existence. Over time, their orbit shrinks. The black holes move closer and closer, faster and faster until they collide. They fuse together, forming a larger black hole. No explosion, no sound, but a colossal release of energy that you can only sense in the soft ripple it leaves behind. We'll get to that soon. But tonight isn't about endings. It's about beginnings, about stillness, about lying under the stars and remembering that even silence can carry a story. Maybe the most profound part of all this is how slow it is. Black holes don't race. They move with the patience of deep time, where 1,000 years is merely a note in a song that stretches over eons. The universe isn't in a hurry, and neither are you. So, as you drift tonight, just know this. Somewhere far away, two massive, unseen giants might be circling each other in the dark. They aren't chasing or fighting, just moving slowly, gracefully, drawn together by an ancient and inevitable pull, a force as old as the stars themselves. You don't need to grasp every detail to feel the poetry in that. Just breathe. Let your thoughts float with them. Let your mind move like starlight, slow, weightless, and free. And as we lie in this quiet understanding, a question emerges. A soft question, persistent, forming just beyond the edges of thought. What truly is a black hole? Let's drift there next. So what exactly is a black hole? You've heard the word. Maybe you see it in your mind, a swirling vortex, a dark tunnel, maybe even a portal. But a black hole isn't any of those things in the usual way we think about them. It's not a hole in the ground, not empty, and not dark the way the night sky is dark. A black hole is gravity, pure and relentless. A place where gravity wins completely, where it becomes so intense that even light, the fastest thing we know, can't break free. To understand how black holes come to be, we start with stars. Not just the pinpoints in the sky above, but the enormous celestial furnaces that live for billions of years. Stars are born in huge clouds of gas, mostly hydrogen, floating in the cold parts of space. When enough gas gathers in one place, gravity starts its quiet work. It pulls inward, tighter, hotter. At a certain moment, the pressure builds so much that hydrogen atoms begin fusing into helium. That's what lights a star, nuclear fusion. An inward pull from gravity balanced by an outward push from energy. It's a kind of perfect cosmic equilibrium. And for most of a star's life, this balance holds steady. But eventually, the fuel runs out. Fusion slows, and gravity, the patient sculptor, begins to win again. In smaller stars, this collapse ends peacefully. The star becomes a white dwarf, small, dense, and quiet. In slightly larger ones, the end is more dramatic, a supernova. The outer layers explode with blinding brilliance while the core collapses. But if the star is enormous, 20 times or more the mass of our sun, then even that isn't enough to stop the fall. The core collapses completely, not just past atoms but past the particles that make them, past anything we can really imagine. And what's left behind isn't a solid object. It's not even an object at all. It's a region, a space where gravity has folded everything inward, and nothing, not even light, can get back out. Here's where it becomes truly strange. A black hole has no edge you can touch, no surface like a planet or a rock. Instead, it has a boundary, a line that marks the point of no return. This line is known as the event horizon. Once anything crosses that invisible border, it's gone. Not because it's crushed or incinerated instantly, but because there is no longer a way back. No light, no time, no sound escapes. Inside this edge, everything is pulled inward toward the center, toward a point we call the singularity. A place where matter is so dense, so compact, that all our physics fall apart. Our equations stop working. It's not just unknown, it's unknowable, at least for now. It may sound frightening, but despite their reputation, black holes aren't chaotic monsters. They don't suck everything around them like vacuums. They aren't roaming the galaxy devouring stars and planets. They're quiet, still, predictable. If the sun were suddenly swapped with a black hole of equal mass, Earth would keep orbiting the same path it does now. We'd be cold and dark, yes, but we wouldn't be pulled in. That's how subtle black holes are from a distance. You could even travel close to a black hole, and as long as you stayed outside the event horizon, you'd feel gravity's pull just like you would near any massive object. Strong, yes, but not instantly deadly. The strange part doesn't end there. Near a black hole, time itself behaves differently. Imagine you're floating in space, just outside the event horizon, while a friend remains far away in open space. You hold up a clock. For you, it ticks at a normal pace. Everything feels the same. But from your friend's perspective, something odd is happening. Your clock is ticking slowly. Your movements are stretched out. Your voice, if it could travel, would sound drawn and low. This isn't a trick of light or a visual illusion. It's something called gravitational time dilation. Time itself is passing more slowly for you, simply because you're closer to a massive object. This isn't just theory. Right now, even here on Earth, your feet experience time slightly slower than your head, just because they're closer to the center of Earth's gravity. The effect is minuscule, but it's real. GPS satellites have to correct for it, or your phone would show you in the wrong place. Near a black hole, though, this becomes extreme. If you were to hover just above the event horizon and somehow survive, you might experience minutes while thousands or millions of years pass for your friend farther out. Black holes don't just curve space. They distort time. They bend the very fabric of reality. And yet, we know they exist, not because we see them, but because we see their influence. We observe stars orbiting around invisible centers. We see hot gas swirling in, glowing as it heats up before crossing the event horizon. We detect X-rays, distorted light, and even shadows, like the famous photo taken by the Event Horizon Telescope in 2019, a blurry ring of light marking the edge of the unseeable. Black holes leave fingerprints. They shape galaxies. They anchor swirling arms of stars. They don't shout their presence, but they sculpt the universe quietly. Think of them not as destroyers, but as keepers, curators of cosmic memory. They gather matter, they hold it, and they wait. Even endings have their own beauty, because black holes are not breaks in the cosmic story, they're a part of the life cycle. Stars are born, stars live. And some stars, after they die, become black holes. And those black holes may linger, or sometimes they find each other. And when that happens, when two of them meet, the result is one of the most elegant events in the cosmos. They don't crash like meteorites. They spiral toward one another. Slowly, gracefully, patiently. Their immense gravity weaves their paths together. Their event horizons stretch toward one another like soft edges of silk. And then finally they merge, not in fire or sound, but in motion, in the reshaping of spacetime. The energy from their union doesn't explode outward in light. It ripples outward in waves of gravity. And this brings us back to those gravitational waves. What is gravity, really? What does it mean to feel a force pulling you even when nothing touches you? What quiet presence keeps your body gently pressed to your bed at this very moment? What draws two black holes into one another's embrace? It's gravity. Right now, gravity is with you, not shouting, not humming, just there, a steady, invisible presence holding you to earth. Like a soft whisper saying, stay, and you do. You don't often think about it, but gravity is working on you every moment of your life. It helped shape you even before you were born. It tells the ocean when to swell. It guides the moon in its path. It fuels stars. It's gentle, but it's not weak. In fact, gravity is the reason anything exists at all. Let's rest there for a while. Picture the universe before stars, before planets, before light. Only cold clouds scattered across space. Still, empty, waiting. Then slowly gravity starts to work. Not urgently, not forcefully, but patiently. It draws bits of matter together, just slightly, just enough. Over time, far longer than we can comprehend, the matter grows denser. The clumps tighten. Heat builds, pressure mounts, and then something begins, fusion. A star is born, that's gravity's work. Not loud, not showy, but unstoppable. It's tempting to say gravity is simply a pull between things with mass. But that's only the surface. Let's try another image. Close your eyes. Picture space not as emptiness but as a soft, invisible fabric. A limitless sheet stretched out in all directions. Now place something on it. Say a marble. The fabric bends beneath it. Place another marble nearby. It rolls toward the first. Not because it's being pulled, but because the sheet curved and guided its path. This is what Einstein taught us. Gravity isn't a force that pulls across space. Gravity is the shape of space. Mass tells space how to bend. Curved space tells things how to move. That's why the moon doesn't crash into Earth. It's moving along a curve created by Earth's shape in space. It's not tethered by a string. It's surfing along a gravitational slope. Black holes, though, they take this to the extreme. They don't just dent the fabric, they plunge into it. They are deep, dark pits in spacetime geometry. Their shape is so steep, not even light can escape. And you are held within this curved geometry right now. Earth presses gently into spacetime. Spacetime responds by curving around Earth. That's why you feel weight. Not because something is pushing down, but because the shape of space is nudging you toward the center of the planet, and your body resists ever so slightly. When you let something go, a pencil, a feather, a memory, it falls not because it's pulled, but because it follows the lines drawn by space's curve. You can't see those lines, but they're there, etched softly by mass, followed by every leaf that drops, every moon that drifts, every star that circles, and even though it all feels ordinary, it's anything but. Think about this. Every time you jump, even just a little, you're resisting the pull of an entire planet. You rise for a moment, and then, like everything else, you return, gently drawn home. Even astronauts orbiting in space are still falling. They're just moving sideways fast enough to miss the ground. That's what an orbit really is, falling forever but never landing. The same is true for satellites, for moons, for stars drifting through galaxies. They aren't suspended by strings. They're flowing in the quiet current of curved space. And black holes, they are the strongest currents of all. Their pull isn't a slope, it's a drop, like a waterfall in the fabric of existence. And once you cross that edge, the event horizon, there's no return. Not because something drags you back, but because time and space themselves have changed direction. They now flow inward. Sometimes two black holes meet. They don't rush, they don't chase, they simply drift closer. Their gravity blends, their motions change, a spiral begins. Not in a burst, not in a bang, but in a slow, perfect circling. Sometimes it takes thousands of years, sometimes billions, and as they turn, they speak, not in sound, not in light, but in waves. These black holes speak not with sound, since sound doesn't travel through space, but with a different kind of ripple. Not water, not light, but gravity itself moving. Imagine a perfectly still pond. You drop a pebble. The water ripples outward. That's what two black holes do as they orbit each other. Their motion disturbs space, not the objects in space, but the very fabric space is made of. They send ripples outward, gravitational waves. These aren't just traveling through space. They are space, stretching and squeezing as they pass through. Each time they circle, another wave emerges. And every wave says the same thing in a new way: we're here. We're circling. We're becoming one. Here on Earth, you won't notice. These waves are incredibly faint, tinier than the width of a proton. They move through you like a whisper you didn't even know was spoken. They stretch your atoms ever so slightly. Then they're gone, but they're real. And as the two black holes spiral faster, their movement becomes more intense. They pour energy into spacetime itself. The ripples become sharper, more frequent. In the language of gravity, this is a rising pitch, a chirp, like a spring winding tighter and tighter. If scientists record it, it almost sounds like a bird calling into the void. But this isn't a sound moving through air. It's a shape shifting in space, a wave born from the changing curvature of the universe. And for a long time, we could only imagine this. Then one day we heard it. In 2015, something extraordinary happened. A scientific instrument with arms stretching kilometers in length, built with incredible precision, finally caught the ripple. It had been traveling for 1.3 billion years. Two black holes had merged far across the universe, and Earth, our planet, trembled just slightly as their wave passed through us. It was the first time we didn't just observe the universe with eyes, we felt it. In the trembling of our instruments we sensed the motion of giants. And so the dance isn't just theory anymore. It's real, measured, witnessed. Two black holes once alone, drawn together not by emotion but by mass, distance, and time. They spin faster, their orbits blur, their edges draw close. Then the moment comes. Their event horizons touch, their cores unite. One black hole is born, the last ripple spreads across the cosmos. A farewell, a beginning, a memory. Even after merging, the new black hole isn't immediately still. It trembles like a bell just rung. It sends out one last set of waves, quieter now. The final chords of a symphony billions of years in the making. And here you are, breathing gently, resting on a planet that just so happened to lie in the path of those waves. A planet where life evolved, where ears and instruments could one day listen. This story began before Earth had trees, before oceans had fish, before we named stars. And now you've heard it too, not with your ears, but with your awareness, with your imagination. Isn't it beautiful that the most massive, silent objects in the universe, the black holes that swallow light, can move with such perfect grace, that their silent dance can echo across galaxies, and that their echo can pass, unannounced, right through your bones? Tonight those black holes rest. Their story has been told through motion, but the ripples, they're still traveling. They're moving beyond Earth now, past distant stars, deeper into the dark. What are these waves made of? What carries them so far, so gently? To understand that, we need to think differently about space itself, not as emptiness but as something, a field, a structure, a fabric. Let's drift there next. Time feels steady here, doesn't it? You can hear it in the tick of a clock, feel it in the rhythm of your breath, the slow rise and fall of your chest, the quiet cadence of the night as it softens over you. But time isn't what it seems. It doesn't tick at the same pace everywhere. And near a black hole, time bends, not suddenly, not dramatically, but softly, like a dream. Picture yourself floating in space near a black hole, not falling in, just hovering near the edge, just outside the event horizon. That invisible boundary where things change. You hold a clock, it ticks. 1 second, then another, everything feels normal. Far away, your friend watches you through a telescope. From their perspective, something is different. Your seconds stretch. Your hands move slowly. Your light grows dim and red. To them, time is racing forward. But for you, it's passing gently at its usual pace. This isn't fiction. It's not a thought experiment. It's part of reality described by Einstein's theory of general relativity. The stronger the gravity, the slower time moves. Not figuratively, literally. Even here on Earth, your head experiences time just a little faster than your feet. And satellites must correct for this to keep navigation systems accurate. But near a black hole, the difference is profound. If you hovered near the event horizon for a few minutes, you might return to find centuries had passed. Civilizations risen and gone, stars born and extinguished, and you barely older than when you left. That's the quiet power of black holes. They don't just bend space, they twist time. So what if you crossed the line? What if you passed through the event horizon? You wouldn't feel it. You wouldn't notice a flash or a shift. You just keep falling, unaware that escape is no longer possible. From your own point of view, everything would seem calm, normal. But to anyone watching from the outside, you'd freeze at the edge. Your image would stretch. Your light would fade. You'd appear suspended forever. That's time breaking down. That's perspective twisting. A black hole isn't violent the way storms are. It's subtle, it's patient. And time near a black hole doesn't rush, it lingers, it waits, it curves. And now, as you lie still, you feel your own time flowing. Not hurried, not stretched, just right. Maybe that's comforting. That time isn't just slipping away, it's listening. It's breathing with you. And when time grows still, perhaps that's when we can feel it most. Now, let's return to the moment just before two black holes join. They've been circling each other for ages. Their paths spiral inward. The gravity between them builds. And right before the final touch, something odd happens. Time slows again. For them, everything continues as expected. But from far away, it looks like a pause. A slow exhale held just a moment too long. And then the contact. The union, the formation of one. Their horizons combine, a new outline forms, a new boundary takes shape. Time begins to move normally once again, and in the space around them the last wave of their journey escapes, a gravitational echo, a farewell note played once. You, lying quietly now, have always lived within time's flow. It carried you from your first moment until now. It will carry you into tomorrow. But black holes remind us that time isn't a straight river. It can pause, it can stretch, it can wait, and maybe that's what makes time so precious. Not that it's always fleeting, but that it can shift, that it can change, that it can hold you gently even when the world is racing by. So imagine now resting just above a black hole's edge, where time thickens, where seconds become centuries, where a single heartbeat might last an age. Would you feel the quiet more deeply? Would your dreams stretch longer? Would rest feel deeper, or would time itself feel like a dream? Tonight, time slows just a little for you. Not because you're near a black hole, but because you've allowed your mind to drift, to wonder, to breathe. And though Earth spins and seconds pass, you are free to pause, to drift, to stretch this moment gently, like silk. Because sometimes, the most powerful thing you can do is simply to rest in the present moment's gravity. As you lie still, wrapped in the comfort of this quiet moment, your mind floats far beyond your room. It drifts toward something vast, something that doesn't need words, something that doesn't shout, space. Even when you close your eyes, the universe doesn't vanish. It lingers behind your thoughts just like the dark between stars, always there, always patient. Now think about space not as emptiness but as a living canvas, soft, bendable, and deeply responsive. Every star that forms, every planet that spins, every black hole that waits, each of them is etched into that canvas. Their presence causes ripples, slopes, and curves. When Einstein described gravity as the bending of space, he gave us more than a theory. He gave us a language, a way to talk about things too vast to touch. But even Einstein might not have imagined that one day we'd listen to those curves. Gravitational waves. They don't shimmer like starlight. They don't roar like a rocket. They pass through everything, stone, water, air, without slowing down, without asking permission. A ripple from two merging black holes traveling for 1 billion years can shift your atoms ever so slightly, less than the width of a proton. And then it's gone. You didn't feel it. No one did. But deep in a quiet facility on Earth, machines caught that shift. Long arms made of vacuum tubes and mirrors noticed that space had stretched. Just a little, just enough. That was LIGO, the Laser Interferometer Gravitational Wave Observatory. It didn't look up at the sky. It waited, arms outstretched, for the universe to speak in ripples. And in 2015, it listened and heard. It was a new kind of astronomy, one that doesn't look but feels. And since then, more waves have arrived. More black holes have merged. More stories have rippled across the stars and arrived in our arms. And we listened. Now other instruments join the dance, Virgo in Italy, KAGRA in Japan, and soon even more. An orchestra of instruments scattered across Earth, each tuned to the silent song of the universe. They don't measure light, they measure distance. Time, movement. They hear the invisible, like a heartbeat beneath all things. And what they hear most often, what arrives again and again, are black holes. Silent, massive, unseeable, and yet so loud in gravity. Some are small, just a few times the mass of our sun. Some are huge, dozens of times heavier. And then there are those even larger, millions or billions of times more massive, lurking in the hearts of galaxies. Supermassive black holes. They didn't form from stars. They're too big, too ancient. We're still learning how they came to be. Maybe they grew slowly, feeding on gas and stars. Maybe they formed suddenly from clouds that never became stars at all. Whatever their story, they sit like anchors in the centers of galaxies, including our own. At the center of the Milky Way, beneath clouds of dust and light, is a supermassive black hole named Sagittarius A*. It's quiet, mostly. Not feeding, not flaring, just waiting, holding the galaxy in its slow, spiraling arms. We've seen stars whip around it at unimaginable speeds. We've traced their paths like loops drawn on a blackboard. Those paths curve not because there's something shining at the center, but because there's something heavy, something dark. We've even captured its shadow. In 2022, the Event Horizon Telescope revealed a blurry ring, a soft, orange circle, the signature of Sagittarius A*. It wasn't a photograph in the usual sense. It was a map of light bent by gravity, a silhouette carved from space. And there, in that image, was the mark of a black hole. It's strange to think that something which swallows light can leave such a vivid image. But that's the paradox of black holes. They are the absence that leaves an imprint, the silence that changes everything. You won't see them in the night sky, no sparkle, no twinkle. But if you could tune your senses to gravity, if you could hear the curves of space itself, you'd notice them everywhere. Whispers of collapse, echoes of creation, pauses in the rhythm of time, and each one tells a story, not of destruction but of balance, of matter finding its resting place, of stars coming full circle. Black holes don't fight the universe. They participate in its quiet logic. They shape galaxies, they slow time, they create waves. And those waves travel. They move through you now just like air, just like night. And as they pass, they ask you to slow down, to listen, to wonder. Because in the heart of silence, there is always something moving. Somewhere another pair of black holes is circling, slowly, patiently, not yet touching, but getting closer. Their gravity whispering, wait, not yet, just a little longer. And when they merge, a new wave will travel outward. A message from two invisible giants, sent to no one in particular, and yet destined for every corner of space. Maybe it'll reach Earth in 1,000 years, maybe 10,000. Maybe one day another listener somewhere, sometime, will lie down quietly and hear it, just like you. And what will they hear? Not noise, not sound, but rhythm, movement, memory. A soft confirmation that they too belong to a universe that moves, a universe that waits, a universe that listens. So rest easy. The stars above may look still, but they're dancing. The black holes may seem silent, but they're singing. And you, wrapped in warmth, held by gravity, are part of that song. Let's drift even deeper now into one of the most mysterious ideas in all of physics, something that black holes quietly suggest but don't explain outright. Information. When something falls into a black hole, it vanishes, yes, but where does the information go? By information, we don't mean letters or files. We mean the physical description of a thing, its structure, its history, its arrangement. A chair burns. The molecules scatter, but the information can, in theory, be reconstructed. A person eats an apple. The apple is gone, but every atom is still somewhere. Physics, as we understand it, insists that information isn't truly destroyed. It changes, it spreads, but it remains tucked away in the math like footprints in wet sand. But black holes challenge this idea. If something falls past the event horizon, we lose all access to it. We can't see it. We can't measure it. We can't retrieve the details. If 1,000 different objects fall in, the black hole doesn't keep a list. It grows. It becomes more massive. But it doesn't tell us what went in. Two black holes with very different histories might look exactly the same from the outside. Just mass, spin, and charge. Everything else gone. That's the puzzle. Does the information truly vanish, or is it hidden, trapped on the event horizon somehow, stored in a way we don't yet understand? This is called the black hole information paradox, and it's not just a curiosity, it's a crossroads. Because on one side of this paradox is general relativity, Einstein's theory, where black holes are smooth and continuous. On the other is quantum mechanics, the theory of the tiny, which insists that information must be preserved. And black holes live at the intersection of those two worlds. They're heavy and massive, yes, but they're also small in scale, at least some of them. That's where our understanding begins to blur, where gravity and quantum physics must meet, but don't always agree. Some scientists think the information escapes very slowly, encoded in the radiation a black hole gives off, Hawking radiation. Others wonder if the event horizon itself somehow stores the data like a cosmic hard drive. Some suggest we may never know, because the answers lie where our tools cannot yet reach. Still, the question matters, because the universe is made of information, and black holes might be telling us something about its deepest code. So as you rest here, drifting gently in this vast, invisible sea, think about how even the quietest things hold mysteries. How a silent object, darker than the night itself, might carry secrets we haven't yet learned to read. And how your mind in this still moment can hold those secrets too, without needing to solve them. Just holding the wonder is enough. And isn't that a kind of understanding? Now let's travel toward another idea, not a paradox, but a possibility. What happens inside a black hole? Not just at the edge, not the event horizon, but deep within. This is a place no one has seen. No light returns. No data escapes. All we have are equations, and even those tremble under the pressure. Inside, all matter continues to fall, pulled inward by the unstoppable force of gravity. And at the very center, if the math holds, we find a singularity, a single point of infinite density, a place where space and time curve infinitely. But infinity is a warning sign. It tells us our current understanding has reached its limit, that we've hit a wall in the way we describe reality. We don't like infinities in physics. They're signs of incompleteness. So maybe the singularity isn't real, not in the way we imagine. Maybe there's something else at the core, a structure, a surface, a new kind of state. Some theories suggest quantum gravity will smooth out the singularity, replace it with something finite. Others propose the core might connect to somewhere else entirely, a different region of spacetime, a bridge. You've likely heard the word before, wormhole, a hypothetical tunnel through space and time, linking two distant regions, or even two different universes. Could black holes be entrances to wormholes? Maybe, maybe not. No evidence yet, but the idea is haunting, beautiful, that a black hole might not just end things but lead elsewhere. Not a dead end, but a threshold. It would take a new kind of physics to know for sure. And we're not there yet, but the fact that we can even imagine it, that's part of what makes us who we are. We dream into the darkness. We ask questions that can't yet be answered, and we wait patiently with instruments stretched toward the stars. Now let's return to something simpler, closer. Your body, you're lying still, breathing gently, feeling the pull of Earth beneath you. That pull is gravity, the same force that bends starlight, that merges black holes, that shapes galaxies. It's with you now, holding you, not as a burden but as a touch. You are made of stardust, hydrogen, carbon, oxygen, atoms forged in stars long gone. Your bones remember explosions you never saw. Your breath echoes with the birth of the cosmos. And the gravity that holds you is the same that draws distant black holes into spirals. There's no difference, really, just scale. So as you rest, know that you are part of this vast story. Not separate, not aside, but inside. Your stillness is part of the motion. Your calm is part of the energy. And your wonder, the simple act of listening, is part of the signal the universe sends back. So lie there. Let your thoughts drift like comets. Let your breathing match the rhythm of curved space. And let the silence of black holes remind you that some things don't have to be seen to be known. That some truths are carried in gravity, not words. And that the deepest mysteries often speak the softest. Now, allow yourself to imagine the sky, not as a ceiling but as an invitation. Not just filled with stars but with memory, with motion, with time. Every star you see is part of a larger structure drifting gently through space. Our galaxy, the Milky Way, is just one of many. Billions of galaxies, each spinning, shimmering, and breathing in their own way. And at the heart of nearly every one, a black hole, not always active, not always feeding, but present, waiting, anchoring the stars around it. In our own galaxy, Sagittarius A*, sits quietly about 26,000 light-years away. You can't see it with your eyes, it doesn't sparkle or glow, but the stars near it move at speeds that defy comprehension. They loop and dive, pulled by a mass that doesn't shine. It's gravity without light, presence without form. And yet we see its influence. It's like watching leaves swirl in an invisible wind. You can't see the air, but you know it's there. Black holes are like that. We rarely see them directly, but we see their pull, their bending of light, their stretching of time, their impact on everything nearby. Even now, as you lie still, your mind can stretch that far. You can drift inward toward that distant center, not to fall, but to understand, to wonder. The Sleepy Narrator invites you to take that journey not as a scientist, not as a student, but as a traveler in thought. Because wonder doesn't require equations. Curiosity doesn't ask for credentials. It only asks that you be still, open, willing to ask what else is out there. Willing to say, I don't know, but I want to. That's how science begins. And it's how dreaming continues. Now let's return to Earth, not because the journey ends here, but because this is where you are. This is where we observe, where we measure, where we listen. And right here we've built machines to hear the universe move. LIGO, Virgo, KAGRA. Quiet instruments with massive arms, mirrors, lasers, and silence. They don't see the sky, they feel it. They record the tiniest tremble, the most delicate shift. A ripple moves through Earth and a mirror shakes by less than a billionth of a meter. And yet that's enough. Enough to say a black hole merged. A star collapsed. A wave passed through. That's the sensitivity of these tools. And they're not just technical marvels, they're acts of patience. They wait. They listen. And when the universe speaks, however briefly, they answer. We've learned to hear things we cannot see, to sense events we cannot visit, to map ripples from 1 billion years ago. And each time we hear a new one, we add a note to the cosmic song. We say this happened. We mark the time. We remember. You are part of that memory. Because when you think about these things, when you imagine black holes or curved space or ancient waves, you become a participant. You don't need to build a telescope. You just need to listen. Now return to the quiet inside you. Beneath the thoughts, beneath the breath. That quiet is not empty, it's full of motion, full of gravity, full of time. And just like black holes, your silence has depth. No need to speak it. Just rest in it. The Sleepy Narrator is here, not to tell you everything, but to keep you company while you explore. Let the imagery drift gently through you now, a pair of black holes circling. Their dance invisible but precise. Their gravity shaping space like 2 fingers tracing lines in silk. Then merger. A new black hole is born. A ripple moves outward. It travels through space untouched. It crosses gas clouds, stars, empty darkness. It enters our galaxy, passes through the solar system, reaches Earth, touches you. Not to harm, not to shake, but to say, I was here. That's all, that's enough. Because black holes don't need to roar to leave a mark. Sometimes the softest signals carry the greatest meaning. A sigh, a whisper, a gravity wave. And now your body rests under the same stars, curved by the same space, held by the same force. You don't have to go anywhere to be part of the story. You already are. Your atoms came from stars. Your mass bends space, however slightly. Your thoughts ripple through time, and in this stillness you can feel the connection, not as noise, but as presence. So breathe slowly. Let go of the need to understand everything. Let wonder be enough. The black holes are still turning, still merging, still sending waves. And you are still listening. Let's drift even further now, not in distance, but in depth. Because while we've spoken of black holes as objects, dense, heavy, dark, they are also gateways. Not to other places necessarily, but to ideas, to the very structure of the universe. And one of the deepest questions we can ask is this: what is space? Not what's in space, but space itself. It seems obvious. A stage, a backdrop, a place where things happen. But what if it's more? Einstein showed us that space isn't passive. It bends, it stretches. It responds to mass and energy. When a black hole forms, it's not a thing dropped into space. It is space curved so deeply that light cannot climb out. A black hole is not an object sitting in spacetime. It is spacetime folded into itself. That's hard to picture. Try this. Think of a fabric, stretch it tight. Place a marble on it, it creates a dent. That dent is gravity. Now keep adding marbles, heavier and heavier. The fabric sags more and more. Eventually, the dent becomes so deep that the marble vanishes from sight. The fabric doesn't rip, but it does fold in a way that hides the marble completely. That's a rough image of a black hole, not a hole in something else, but a region of space whose shape is so intense it becomes unreachable. From outside, you can never see what happens beyond the edge. From inside, you can never return. Now, imagine that instead of fabric, the surface is time itself. A black hole doesn't just trap light, it traps time. When you approach the edge, time slows, cross it, and time bends inward. You don't fall through space. You fall through time. This isn't metaphor. It's what the equations say. And if that feels strange, it should. You are used to time as steady, one-directional. But black holes show us time is flexible, and perhaps, in some cases, reversible. These are not science fiction fantasies. These are real implications of our best theories. We don't have to stretch truth. Reality is already stranger than fiction. Now let's speak about another part of black holes, something often forgotten. Their simplicity. Despite how complex they sound, black holes are, at least on the outside, remarkably simple. They can be described with just a few numbers. Mass spin, electric charge, that's it. You could throw in books, planets, stars, and once inside, the black hole doesn't reveal the difference. From the outside, only those three traits matter. This is called the no-hair theorem, a poetic name for a stark idea. Black holes have no hair, no features, no memory of what created them. They smooth out everything. And yet, they're not all the same. Massive ones spin differently. Some feed. Some starve. Some merge. Others drift alone. And every time we observe their behavior, we learn a little more. We're beginning to map not just where they are, but how they form. Some black holes come from the deaths of massive stars. Others may come from collisions of smaller ones. Still others might have formed in the early universe, primordial black holes, tiny, ancient, and hard to find. We haven't detected those yet, but we look. Because if they exist, they could explain dark matter, the invisible substance that shapes galaxies but doesn't shine. Black holes might be part of that puzzle, so we keep listening, and the universe keeps sending signals. Now let's return to that moment, the merging of two black holes. We've spoken of the waves, the spiral, the union, but what happens after? The new black hole for a while is not stable. It wobbles, it vibrates, like a bell struck softly. These vibrations also send out gravitational waves. We call them ringtones. And from their frequency, we can learn the mass and spin of the final black hole. It's like hearing the tone of a bell and knowing its size. Even in silence there is music, and black holes are some of the deepest instruments. Low, long, gentle. If you could hear gravitational waves as sound, they would be more like breathing than thunder, more like a heartbeat than a drum. And perhaps that's why we find them so comforting. They remind us that the universe isn't always sharp. Sometimes it moves softly, sometimes it rests, and sometimes it simply waits. Right now out there, black holes are merging. Right now, waves are traveling toward us. And when they arrive, we won't see them, but we'll feel them. Our detectors will tremble, our data will shift. And somewhere someone will say, there it is. Another note in the cosmic song. And you'll be part of that too. Because each time you wonder, each time you listen, each time you imagine, you are keeping that song alive. You don't have to measure the ripples. You only need to be moved by them. So breathe now. In, out. Let the rhythm of the night match the rhythm of the stars. And as your thoughts grow quiet, let the gravity of this moment hold you still. Not pulled, just present. Now let's drift through something even stranger, something soft-spoken and vast. Something wrapped in shadow but full of meaning. Entropy. It sounds like a heavy word, and in some ways it is, but at its core, entropy is about order, or rather the fading of it. A room gets messy over time. A hot drink cools, ice melts. Things tend toward disorder, toward evenness. Entropy increases. That's the rule the universe follows, and black holes follow it too. In fact, they are champions of entropy. When something falls into a black hole, the total disorder of the universe increases. And oddly, the black hole itself seems to store that entropy on its surface, not inside, but along its horizon. This is one of the most surprising insights of theoretical physics, that the surface area of a black hole, the area of its event horizon, is a measure of its entropy, not the volume inside, the surface. This led to something remarkable, the holographic principle. The idea that maybe all the information contained in a region of space is encoded not in the space itself, but on its boundary, like a hologram, where a 3D image is projected from a 2D surface. This isn't just a metaphor, it's a serious proposal in theoretical physics, and it was black holes that pointed us in that direction. Think about that. Objects that don't emit light, that swallow everything, that seem to erase what falls into them. These are the very objects that taught us how the universe might store information. And so, in their silence, black holes speak volumes. They remind us that space is not empty, that boundaries matter, that surfaces can hold secrets. Maybe even your own experience reflects this. You think the world is inside you, your thoughts, your memories, but maybe it's also outside you, around you. Maybe your awareness is written across a boundary, between self and other, dream and waking, thought and quiet. Maybe that's what sleep is, a soft collapsing of boundaries, a merging of inner and outer, a kind of gravitational wave of the mind. Now, as your breathing slows, feel the surface of your body, the place where you meet the world, the horizon of you. There the air touches skin, the bed supports bone, and your presence expands outward. You, like a black hole, shape your surroundings, not with mass but with being. Your gravity is your attention. Where you place it, things move. Even thoughts bend. Even silence curves. Now let's imagine one more black hole, not merging, not feeding, just drifting, alone between stars, cold, quiet, invisible. There are likely many like this, wandering the galaxy, remnants of long-gone stars, moving through space without light, without noise. We don't see them, but we feel their pull. Sometimes they pass near stars and bend their light, gravitational lensing, like a glass sphere distorting the view. This bending lets us find them even when they're hidden. Even the invisible can leave marks. And so it is with feelings, with memories. You can't always see them, but you know they're there. Their pull is real. Their shape is true. You are full of such marks. Ripples of past events, curves in your own spacetime, some healed, some still echoing. And like the astronomers tracing light curves, you learn to read them, to listen to what can't be spoken, to notice what isn't obvious. That's part of what makes you vast, too. You are not simple. You are not empty. You are curved, shaped, full of meaning, full of softness, full of space. The Sleepy Narrator is here to remind you of that, not by teaching, but by gently guiding, by letting you feel it for yourself. Now, let the idea of black holes fade for a moment. Let the metaphors rest. You are lying still, that's enough. No thoughts to chase, no answers to seek, just gravity, just breath, just the quiet presence of a universe that continues even now. Somewhere, another black hole has just formed. Somewhere, another wave has just begun. Somewhere, another star has flickered out. And somewhere else, a new light has just appeared. The story goes on. And so do you. Let your mind float now, not to the stars, not to distant galaxies, but to the space right here. The space between thoughts, between breaths. This is where the story continues, because black holes aren't only about mass or motion or math. They're about stillness, about limits, about boundaries that speak without words. Let's return to the edge of one, the event horizon. It isn't a wall, it's not solid, you wouldn't bump into it. It's a boundary drawn by time. If you fall past it, you won't feel it. But you've crossed a threshold, a line where the future narrows, where every path, every option, every trajectory now leads inward. Even light must go in, no escape. Not because something pulls, but because there is no out to move toward. The shape of time itself has curved. Imagine that. A place where time no longer flows in every direction. A place where time and space have traded roles. Inside a black hole, time draws you inward. You don't fall because you're being pulled. You fall because that's the only future left. That idea is more than strange. It shifts how we think about motion, about cause, about choice. It means black holes are not just traps, they are destinations. Once you enter, the future is no longer ahead, it is inside. And yet from the outside you still seem to hover, frozen in time, a paradox, only from one view. Perspective is part of physics now. What you see depends on where you are. What feels normal to you might look impossible to someone else. This relativity is not an illusion. It's built into the universe, and black holes show us that more clearly than anything else. They are truth wrapped in mystery, stillness wrapped in movement, finality wrapped in time. And here you are thinking about them, not watching them fall, not feeling their pull, but letting your awareness sink gently into their shape. Isn't that a kind of gravity too? Now let's return to the space around black holes. Not the horizon, not the core, but the dance. Because many black holes aren't alone. Some orbit each other, spiraling closer over time. Others orbit stars, feasting gently, pulling gas into spirals of light. And in rare cases, stars orbit black holes in tight, elegant loops. We've observed these dances, and they are precise. The orbits follow strange paths, not ellipses but flower-like spirals. Each loop shifts slightly, pulled by curved space. This effect, called precession, is another signature of Einstein's gravity, and we see it. In the stars near Sagittarius, a asterisk. Their orbits draw out petals, not circles. Their motion is poetry, written in gravity, and we watch from afar, reading the curves. We don't need to go there to understand. We just need to observe, patiently, carefully. That's the beauty of astronomy. It asks you to look, not to change things, not to fix them, but to witness. And witnessing is enough. In your own life you may have felt that. Moments when nothing could be done, but something could be seen, felt, held. Black holes teach us that even when light cannot escape, the shape it leaves can still be known. Even when something vanishes, its gravity remains. Even when a future narrows, it can still carry meaning. So if there's a heaviness inside you, a sadness, a memory, a silence, you don't have to fight it. You can just observe. Let it orbit. Let it spiral. Let it rest. Now think again about gravitational waves. These are not explosions. They are not flashes. They are ripples. Soft, stretching waves that carry motion across the fabric of the universe. When two black holes merge, the wave isn't violent. It's smooth, it builds, it crests, it fades, and Earth moves just slightly as it passes. You moved. You didn't feel it, but your atoms shifted. You were part of that merger. Not by choice, not by effort, but simply by being here. That's the kind of connection we rarely feel, but it's real, not emotional, physical. And you don't have to do anything to earn it, just exist. That's enough. Now let's drift even further, not away from the topic, but deeper into its center. Because black holes don't only challenge our physics, they challenge our language. How do you describe something that hides everything? How do you explain a place where time ends? How do you speak of a silence that moves? Poets have tried, physicists too. They use math. They use metaphor. Both are useful, but neither is complete. Maybe the right response isn't explanation. Maybe it's listening. Listening to the quiet curve of gravity. Listening to the breath of space. Listening to your own curiosity as it turns inward, and finding not an answer but a path. Black holes do not end the story, they extend it. They invite new questions, new physics, new wonder. They are where our understanding thins and where new ideas are born. That's not failure, that's a frontier. And you drifting quietly in thought are already there. So rest in that mystery. Let it hold you. You don't need to solve it. Just float near it, like a star skimming close to the edge, glowing, curious, still intact, not falling, just noticing. Even now the universe curves around you, your mass bends space. Your breath passes through time. You are not separate from these things. You are part of them. You are one more ripple, one more orbit, one more curve in the quiet fabric of all that is. Picture yourself now floating slowly in the dark space between stars. The kind of darkness that isn't empty but full of time, of energy, of unseen stories. Here, the silence is rich. And from within that quiet, black holes continue their whispering influence. They are not rare, not distant curiosities. They are common, perhaps as many as one for every 1,000 stars in the galaxy. Some are small, stellar remnants. Others are giants in galactic cores. And between those extremes, there may be black holes we've yet to understand. We're just beginning to chart them. And each time we find one, we learn something not only about it, but about space itself. Because a black hole does not exist alone. It distorts its surroundings. It warps light. It affects time. And by tracing those effects, we discover its presence. That's how we found the first ones, not by seeing them but by noticing stars moving strangely, as if orbiting an invisible partner. In 1964, we observed a star, HDE 226,868, behaving oddly. It moved in a tight orbit. Its companion was unseen but heavy. Later, we found the source emitted powerful X-rays, and thus, Cygnus X1 became one of the first serious black hole candidates. It wasn't just theory anymore. It was evidence. That changed everything. It meant the universe wasn't only filled with possibilities, it was filled with confirmations. What was once imagined had now been observed. Since then, we've found many more, with X-ray telescopes, with gravitational wave detectors, with radio telescopes. Each tool adds a new lens. Each lens shows us a different face of gravity. Some black holes glow brightly, surrounded by hot gas spiraling inward. Others remain hidden, only discovered by their gravitational pull. And some are revealed when they merge, shouting momentarily in spacetime, then falling silent again. All of them remind us, darkness is not the same as absence. Sometimes the most powerful things don't shine. Sometimes they curve instead. And your thoughts can curve that way too. You can turn inward, not to hide but to reflect, to notice the pull of your own inner gravity. You are not lightless. You are luminous in other ways, in how you imagine, in how you care, in how you listen even to something as quiet as the idea of a black hole. Now think of spin. Black holes can rotate, just like planets, just like stars. Their spin shapes the space around them. It twists it, pulls it into a whirl. Near a spinning black hole, space doesn't sit still. It flows. This effect is called frame dragging. If you could hover near such a black hole, safely at a distance, you would find that space itself was moving around you. Not because you're traveling, but because space is. Like leaves on a river, you'd be carried along. You'd orbit even if you tried to stay still. Time itself would flow differently depending on your direction. One path would move faster, another slower. This isn't science fiction. It's been measured even near Earth. A satellite called Gravity Probe B confirmed that Earth's spin slightly twists the space around it. Barely noticeable, but real. And near a black hole, that effect grows powerful. So now we understand, space is not passive. It isn't just where things happen, it participates. It bends, it spins, it remembers. This insight brings us back to something deeper. The idea that space and time are not just stages but actors. They respond to mass. They ripple with energy. They carry information. Even as you rest here, letting your thoughts move slowly, your body exerts gravity. You are shaping the space around you, infinitesimally, but truthfully. Every cell, every breath, every heartbeat, you are part of the system. Connected, real. Now return to that most silent moment, the birth of a black hole. When a star collapses, its fusion ends. Its outward pressure fades, and gravity, no longer held back, takes over. the core implodes. The surface may explode, a supernova, but the core continues falling, and if the mass is enough, no force halts it. A black hole forms, not with fire, not with a roar, but with inevitability. This is not destruction, it's transformation, a shift from one state to another. And though we often think of black holes as endings, they are beginnings too. The beginning of new orbits, new interactions, new waves. The black hole becomes part of the next chapter. And in some cases, it might even give birth, not to light, but to structure. Some theories suggest black holes may help seed galaxy formation. They may anchor the growth of stars. They may shape the very order of the cosmos. So once again, black holes are not enemies of light. They are partners in the dance. Without them, the universe might look very different. Now, think about this. You are made of atoms born in stars. Your body is full of carbon, oxygen, iron, all created in stellar cores. When stars die, they release these elements, and sometimes their deaths create black holes. So in a quiet way, black holes and life are connected, not opposed, not distant, but related. You are the result of stars that lived and died and maybe even collapsed. The calcium in your bones, the iron in your blood, the carbon in your breath, all from stars. And black holes are part of that story, not by shining, but by allowing structure, by drawing matter together, by curving space in a way that creates paths for things to follow. Your body follows paths too. It ages, it remembers, it holds. And in its stillness tonight, it also listens. It listens to ideas, to dreams, to gravity, to the hush of a universe that continues without noise, but never without motion. So let yourself drift again, not into sleep, but into peace, into the calm assurance that you are part of something vast. You don't need to prove it, you don't need to change it, you only need to rest in it. Let your thoughts glide now into the oldest parts of the cosmos, those first few moments after the Big Bang, a time when the universe was young, dense, and hot, when matter and energy danced in close quarters, before galaxies, before stars, before even atoms had fully formed. In that seething soup of particles, some theorists believe black holes might have been born, not from stars, but directly from density. Tiny fluctuations in mass, squeezed by gravity, could have collapsed into micro-black holes. These would be ancient, primordial, smaller than stellar black holes, much lighter, and if they exist, they might be everywhere, wandering unnoticed, difficult to detect, too small to shine, too quiet to disturb much. Yet they could carry answers. Because if we find them, they might explain dark matter, the unseen mass that helps galaxies hold their shape, the matter we feel but don't see. Primordial black holes are one possible explanation, a different kind of darkness explaining another. And so we look. We build detectors sensitive enough to pick up their tiny effects. We measure star movements. We map lensing events. We compare light curves and hope for a pattern. So far, no clear evidence, but the possibility remains that some of the most ancient objects in existence are all around us, not in the sky, not in telescopes, but in the dark between stars, floating through galaxies, shaping space in silence, waiting. And perhaps that's a good word for this kind of science, waiting. Astronomy isn't only about discovering, it's about listening, about watching the same patch of sky for years, about building instruments that wait patiently for a single brief signal, a single ripple, a single flicker. And often those moments don't arrive on schedule. They come unannounced, like a gravitational wave passing through Earth, or a sudden dip in starlight hinting at a distant planet or maybe something else. Waiting is hard, but it's also powerful, because in that stillness we prepare ourselves to notice, to recognize, to say, there, that's something new. That's the signature of a black hole, or the birth of a star, or just the graceful curve of light bending gently around mass. Even the smallest shift can hold meaning, and in your own mind, waiting matters too, letting a thought settle, letting a feeling unfold, not rushing it, not solving it, just witnessing. Your mind, like space, holds shape. It has curves. It responds to presence. And sometimes its greatest clarity comes from doing less. Now let's look forward again to the far future. Billions of years from now, most stars have died, new ones form slowly. Galaxies begin to drift apart, and black holes, those great survivors, remain. Over unimaginable spans of time they may collide, merge, grow, and slowly, very slowly, they will begin to shrink, because black holes aren't perfectly silent. They emit something, not light but radiation, called Hawking radiation. This idea, proposed by Stephen Hawking in 1974, changed everything. It said that black holes are not eternal, they lose mass, bit by bit, photon by photon, very slowly, so slowly we can't yet measure it. But in theory it means even the largest black holes will one day fade. They'll evaporate. They'll shrink until eventually they vanish. Not with a bang, but with a whisper, leaving behind only the smallest imprint. A soft sigh in the data of the universe. And when that day comes, the universe will be even quieter. No stars, no planets, just drifting particles, and perhaps memory encoded in the patterns, in the radiation, in the shape of the void. It's a long view, a far view, but it reminds us everything changes, even black holes, even silence, even time. So if you're holding on to something that feels permanent, know this. Even the most stubborn things shift. Even the darkest places transform. There is movement everywhere, not always fast, not always visible, but real. Now return again to your own gravity, to the shape your presence leaves in the world around you. You may not think of yourself as heavy, in the physical sense, but your attention has weight. Where you place it changes things. Where you listen, space opens. Where you wonder, time deepens. And in this moment your gravity is enough. Enough to shape thoughts, enough to shift mood, enough to invite stillness. So breathe with that awareness. Breathe as if you are orbiting your own center, not circling a black hole, but circling calm, curving gently around peace, because you are not falling. You are choosing to stay close, to remain with the silence, to drift on the soft current of curiosity. Let your thoughts drift toward the fabric of space itself, not the objects in it, not the stars, the planets, or the black holes, but the very structure that holds them all. Spacetime. It's not an empty box, it's more like a soft sheet, a subtle field, a geometry that responds to presence. When something with mass enters space, the fabric bends. The more massive the object, the deeper the curve. This isn't metaphor. It's measurable. Light curves around stars. Time slows near heavy objects. GPS satellites orbiting Earth must account for both effects, space bending and time stretching, just to work accurately. Our technology relies on these truths, but black holes take that bending to the extreme. They're not just dense, they're folds, so steep, so complete that nothing, no particle, no light, no information, can climb back out once it falls past the edge. That edge again, the event horizon, it's more than a line, more than a surface. It's a point of no return, not because there's something there, but because beyond it all paths point inward. Imagine a funnel so deep that every drop rolls to the center, no matter where it lands. That's the nature of a black hole's horizon. Not a wall, not a hole, a shift in the very shape of direction. And once you pass it, the future leads only one way. Not because you're being dragged, but because there is no other forward. Forward becomes inward. And yet, from a distance, everything slows. To an outside observer, someone falling into a black hole seems to freeze at the edge. Their light gets redder. Their image stretches. Time appears to stop. Of course, for the falling object, time continues. But for someone watching, it doesn't. This isn't an illusion. It's a feature of relativity. Time is not absolute. Your now is not the same as mine when gravity changes. And near a black hole, that difference becomes profound. This opens doors to questions we can barely grasp. What does it mean for information to fall in? Is it lost? Or is it somehow preserved? Physicists still argue. Some believe black holes destroy information. Others believe it's encoded in the horizon. Still others think it may escape as radiation. No one knows for sure. And yet, despite the mystery black holes teach us, they challenge our assumptions. They force precision. They ask us to think beyond what's visible, and in that way they resemble something else, something quieter, something human, curiosity, because curiosity also bends space. It also leads inward. It also pulls you toward things you don't yet understand. And just like falling into a black hole, curiosity changes you, not quickly, not violently, but deeply. You don't emerge the same. Now think about the tools we've used to study black holes. Not just telescopes and detectors, but mathematics. Math is our spacecraft for exploring where light can't go. With it, we've mapped the behavior of time near black holes. We've predicted their temperatures, their spin rates, their radiation. And sometimes the math goes beyond what we can yet test. But that's okay. Because theory is part of science too. It gives us direction. It guides observation. And sometimes it waits decades before being proven. Einstein predicted gravitational waves in 1916. We detected them a century later. Patience matters. Now, think about your own patience. What quiet truths have you waited for? What questions have circled your mind for years? Maybe they don't have answers yet. That's all right. Sometimes asking is enough. Sometimes the orbit itself is the lesson, not the destination. Just the curve. Now let's step outside even the black holes themselves. Let's look at how they affect their surroundings. In the centers of galaxies, supermassive black holes don't just sit still. They interact, they feed, they flare. They shape the motion of millions of stars. And when they consume matter, they light up. Not the black hole itself, but the gas spiraling inward. Friction heats it. Magnetic fields twist it. It glows across the spectrum: X-rays, radio waves, visible light. These luminous centers are called active galactic nuclei, quasars. Some are brighter than entire galaxies. But the light comes not from the whole, but from the fall, from the last moments before crossing the horizon. That fall releases energy, incredible energy. It's like a final shout before silence, and it tells us something else. That endings can be bright, that collapse can create light, that even in loss there can be radiance. So if you're holding something heavy, some regret, some grief, know that brightness can come from descent too, not just ascent, not just rising. Falling into stillness can release beauty, just like gas spiraling into a black hole, just like light flaring before the edge. Now feel again the calm around you, the gentle curve of your own thoughts. You don't need to calculate anything. You don't need to solve the universe. You only need to let its strangeness wash over you, to feel the weight of these ideas, not as burden but as comfort. Because the more you learn about black holes, the more you realize. They're not monsters, they're not errors, they're features, built into the fabric, as normal as stars, as steady as orbits, as expected as gravity itself. And they don't ask to be feared, only to be noticed, to be wondered at, to be included in the story. So include them now, in your quiet, in your breath, in the steady orbit of your attention. Let your attention settle now, not on distant galaxies, but on the space between your thoughts. This quiet space has gravity too, a subtle pull, a gentle bending of awareness. You're still thinking of black holes, but maybe now they feel different, less like devourers, more like teachers. They teach us about limits, about endings, about how even silence can have shape. And they also teach us something unexpected, about balance, because black holes don't grow endlessly. They require fuel, gas, stars, dust, and when they run out, they rest. Even the brightest quasars fade. Even the hungriest black holes sleep. In those moments, their surroundings can regrow. Galaxies can settle. Stars can form again. So black holes are not only destroyers, they're also regulators. They control their environments. They prevent runaway growth. They keep cosmic systems in check. Too much gas and a galaxy becomes unstable. But a feeding black hole uses up the excess. Its radiation pushes gas away, cooling it, like a thermostat, maintaining balance. It's strange to think of black holes as caretakers, but nature often works that way. Even the harshest forces play roles in larger systems. Even destruction creates room. You may have felt that in your own life. An ending that cleared space, a loss that brought clarity, an emptiness that let something new grow. Black holes echo that pattern. They are not evil, they are structure. And structure, even when silent, creates possibility. Now come closer to the center of a galaxy. Not just any galaxy, but your own. The Milky Way. At its heart lies Sagittarius, a asterisk, a supermassive black hole. We've seen stars orbiting it. We've watched their curved paths. We've measured the mass that must be hidden there. Over 4 million times the mass of the Sun, all in one point. We used to think black holes were theoretical, but now we've photographed one. Not Sagittarius, a asterisk, but another in a different galaxy. M87. In 2019, the Event Horizon Telescope revealed its shadow, a ring of glowing gas, a dark center, an image that stunned the world. Not because it was unexpected, but because it was real. We saw a black hole's edge. We confirmed what equations had predicted. And in that image we glimpsed something ancient. Not just the object, but our own journey. Our long search to see what hides in the dark. Our refusal to stop wondering. That photo wasn't just science. It was art. A portrait painted in light and gravity. And soon we imaged Sagittarius, a asterisk too. Fuzzier because it flickers faster, but still visible, still there, right at the center of us all. Quiet, patient, real. So tonight, as you think of black holes, remember they are not far away. They're not alien. They are part of your home. They sit at the heart of your galaxy, and perhaps at the heart of others too. That symmetry is soothing. Every galaxy a spiral of stars, every spiral a hidden weight, every weight a balance. That's the rhythm of the universe. Not chaos. Not perfection, but balance. Now take a breath. Let it flow in. Let it drift out. Like matter falling toward a horizon. No resistance. No effort, just motion, just presence. Your breath curves space too. Your mass bends time. You are not separate from these truths. You are part of the same geometry, the same rules, the same beauty. Let's return now to Hawking radiation. We said black holes aren't perfectly black. They glow faintly, not from within, but from the edge. Quantum mechanics tells us that particles appear and vanish near horizons. Normally they cancel each other out, but near a black hole one may fall in while the other escapes. That escaping particle is radiation. It costs energy, and so over time the black hole shrinks. This is a slow process, far too slow to observe now, but it matters, because it tells us something profound. Even the most absolute things fade, even the deepest gravity releases, even black holes die. This is not tragic, it is peaceful, a return of energy, a closing of loops, a soft exhale after eons of stillness, and it reminds us nothing is forever, not stars, not orbits, not even questions. Everything curves back, everything folds inward, everything rests. So let your own thoughts rest too. You don't need to chase the answers. You don't need to explain it all. Just notice. Just orbit gently around the idea, like light circling a horizon, like gravity bending a path, like a thought curving through sleep. You're already in motion, already part of the dance. Let's travel even deeper now, not into a black hole itself, but into the ideas they stir up. Because once you've wandered near their edge, a simple question remains. What lies at the center? At the core of a black hole is a point of infinite density, or so our math suggests. It's called a singularity, a place where equations break down, where gravity becomes limitless, where space and time twist into extremes we don't fully understand. But here's the quiet truth. No one's ever seen a singularity. We don't know if they exist as described. Maybe they're real. Maybe they're smoothed out by quantum gravity, whatever that might be. Maybe they're not points at all, but loops or strings or other shapes we haven't imagined yet. Our theories go only so far. Then they fall in two. This is where physics becomes humble, where we admit the limits of knowledge, where we say, here the math ends but the mystery continues. And that's okay. The universe doesn't owe us clarity. It offers us clues. It invites us to ask. And when the answers don't come, we stay curious. That's the spirit of exploration. Not conquering but listening. Not certainty, but awe. You can feel that too, in your quiet, in your questions. In the places inside you that don't yet make sense. You don't have to solve everything. You can sit beside the unknown and still feel whole. Now, imagine something different. A star, heavier than the sun, collapses. But maybe, just maybe, it doesn't become a black hole. Maybe it hovers at the edge. Maybe it becomes something else. Physicists have imagined these possibilities: gravistars, boson stars, fuzzballs. Each one a different path the universe might take instead of forming a black hole. Each one consistent with certain equations. Each one a way to avoid the singularity. We haven't seen them, but we can't rule them out. And so we wonder. We run simulations. We look for signs. And even if these objects don't exist, thinking about them teaches us more about what does. That's how science grows, by testing boundaries, by imagining what lies beyond the horizon, not just in space, but in thought. And isn't that what you're doing too? Sitting in this still moment, wandering through cosmic ideas, letting them stretch your imagination. You're not just learning facts, you're expanding your view, and in that expansion there is room to rest. Let's go back now, far back to the beginning again, to the early universe. We mentioned that black holes may have formed there, but they may also shape what comes next. Some theories suggest that inside a black hole, there might be a new universe. That falling into a black hole might be like falling into another Big Bang. The math allows it. The shape of space could close off from our universe and open into another. A kind of cosmic branching, a tree of realities. Is this proven? No, but it's not ruled out, and it shows how black holes aren't only about endings. They might be beginnings, seeds of other places, other times, even other laws of physics. Think of that. Every black hole as a potential birth, a portal not to nothing but to something, unreachable by us, but perhaps real nonetheless. If that's true, then the universe is bigger than we think, not just vast in space, but vast in possibility. Not one cosmos, but many, each with its own story. And your mind is touching that idea now, floating quietly near a concept as large as infinity. You don't need to believe it, just let it be near. Let it glow gently at the edge of your thought, like the halo of gas around a distant black hole, shimmering, curious, silent. Now let's come home again to your breath, to your body, to this quiet space you're resting in. You've traveled far through time, through gravity, through the shape of thought. And now you're here, still curious, still listening. You carry all that space inside you, all that wonder and all that peace. You don't need a telescope to feel connected. You don't need equations to touch truth. You are already part of the pattern, of the motion, of the quiet beauty that holds it all. So lie back now. Let the last edges of this story fade. Let the curves of space smooth out. Let your thoughts spiral inward, not with force but with ease, like light drifting toward a horizon, not fearing the fall but resting in it. You've journeyed far now, not in distance but in thought, through the bends of gravity, the silence of singularities, and the strange comfort of cosmic mystery. Black holes have guided you, not as destinations but as doorways, not as answers but as invitations to stillness, to wonder, to something beyond the noise of daily life. They've shown us that time can stretch, that space can fold, that light can orbit, that silence can hold meaning, and that curiosity, quiet, steady, slow, is powerful. As we reach the end of this journey, take a moment to breathe, not because you must, but because it's good to, because it reminds you that you're here, that you're part of this story. Your breath is a motion, your thoughts are orbits, your presence curves space in its own way, and that's enough. Let's reflect now on where you've been. You've wandered near the edge of event horizons, learned about time slowing near massive objects, felt the rhythm of stars dancing near black holes, watched gravitational waves ripple across spacetime, and listened, always listened, to the quiet voice of the cosmos. Black holes didn't shout, they didn't demand, they just curved, and you followed the curve, not all the way in but close enough to feel the pull, close enough to understand, not with equations but with stillness. And now you carry that with you. The knowledge that even in the most extreme places beauty remains, that even collapse can glow, that even silence can shine. Remember how black holes aren't black. They emit faint radiation. They hold swirling disks of light. They mark their presence with motion and orbit. Even in hiding, they reveal themselves. You might be like that too, sometimes unseen, sometimes quiet, but still shaping the world, still part of the pattern, still glowing in your own way. Let's remember too how black holes are not only ends but beginnings. They may give birth to galaxies. They may fuel star formation. They may lead to new universes. Even as they pull inward, they open outward. That's the paradox. That's the lesson. That from limits something new can emerge. That boundaries can contain potential. That falling can be part of becoming. And in your own life, that may be true as well. The hardest moments, the ones that fold your time, that slow your light, can also be where something starts. Something unseen, but real. Let that thought rest with you. Let it curl up beside you like a quiet orbit. No need to analyze it. Just let it be. We spoke too of perspective. How time near a black hole differs depending on where you stand. How one person sees motion while another sees stillness. How relativity is not just physics, it's a reminder. That truth can vary with viewpoint. That understanding comes not only from facts but from empathy. You've practiced that here, by listening, by letting go of needing everything to be solved, by allowing mystery. You've walked the edge of not knowing and stayed calm. That is strength. That is presence. Now picture the night sky again, the vast dome above you, speckled with stars, most of them never seen with the eye, but there, always. Black holes don't light that sky, but they shape it. They sculpt its structure. They hold its balance. Without them, galaxies would fly apart. Without them, matter would drift without rhythm. So the stars you do see owe their pattern to what you cannot, just as your thoughts may rest upon things unspoken, just as your calm may be shaped by what lies beneath, invisible but strong. Now, think again of gravitational waves, of how one night in 2015 two black holes collided, over 1 billion light-years away, and their union rippled across the universe, reached Earth, moved detectors, moved atoms, moved you even if you didn't feel it. That moment was soft, not loud, not bright, but profound, because it showed that we're connected, not metaphorically, physically. We're part of the same fabric, the same field, the same quiet motion. You are not separate, you are not distant. You are curved space, you are stretched time, you are gravity and orbit and balance, and you are here, listening still. As we close, take one more breath. Let it be deep, let it be slow. Feel it settle, feel it expand. You are not falling into a black hole, you are falling into rest, into ease, into a space without force, but not without shape. You have shaped this space, with your presence, with your attention, with your willingness to wander slowly through ideas that don't demand urgency. You've done something rare, you've waited, listened, trusted that silence has depth, and it does. So let this final silence hold you. Let it cradle you like the curve of spacetime around a star. Let it be a place to pause, to reflect, to simply be. Because in the end, that's what black holes teach best. That being doesn't always need motion. That presence doesn't always need light. That stillness is not emptiness. It's elegance, it's completion. And you've arrived, right here, right now, with everything still gently orbiting, everything still gently stretching, and everything still waiting quietly to be noticed again. Whenever you return, this has been the Sleepy Narrator. Thank you for drifting with me. Until next time, take care of yourself and have a good night.